As we just talked a little bit about, Diana and I are going to talk for the next 45 minutes about architecture over architects. But what we're really going to talk about is...
is how to make this work.
We're going to talk about stuff that hurts. So, because, again, like loads of stuff is changing and software is changing all the time, and architecture doesn't seem like sometimes like it's keeping up. So Diana and I are going to start off by talking about the things that architecture tells us we should do, and we're going to talk a little bit about the way that architects say that we should do things, and we're going to be honest, and we're going to tell you why that hurts sometimes and why we think that's why we think that hurts, and then we're going to try and share a little bit about what we think we can do differently to maybe make architecture work again. So Diana's got some experiences she's going to share with you.
I love that opening with pain, because that's the great common denominator. Whenever we work with groups, it's interesting how much we have in common in the ways that we're struggling. So I work predominantly in information systems. So over the last 10 years, my work has shifted from building the monoliths that drive web and digital information to working in systems of interrelated software and infrastructures, code and platforms and event-driven platforms. And this has required me to have a constantly evolving skill set, right? So I used to call myself a full stack developer. I don't even know what that means anymore, right, to be a full stack developer. And I often now work with clients that I worked with in the beginning, so I helped build the monolith, and now everyone wants digital transformation. Like, how do we move towards decoupled systems? And so I've architected some really big transformations, and I've had some great fun and some great success, and also seen spectacular failures. And what's interesting is it's often the same circumstance that was successful. Twice now, I've done a big initiative, and at the end, almost all the C-levels were no longer with the organization. So it's been quite an adventure, and I really wanted to understand why. Why do we succeed, and why do we struggle? And the more I looked at this, it wasn't the obvious stuff. It isn't, we don't know enough about Kubernetes. I mean, that matters, and it's helpful, but it really wasn't the why. And so there's one iceberg that we kept hitting, and that is that we don't think in systems. That as we were moving from software thinking to systems thinking, we were using software thinking to build systems. And we aren't trained or set up for thinking, communicating, designing, decision-making as relational complexity increases. And it isn't advanced engineering, it's a somewhat different skill set that we have to bring in and cultivate in order to be able to operate better as we move from software to systems. And so what we found, what Andrew and I have both experienced, is that organizations can change inside their current paradigm. If the world around them is relatively stable, their processes tend to work to deliver change. But if their paradigm shifts, if they're in a world that has changed around them, they really struggle, right, to change their processes and approaches in order to transform. In order to transform, we actually have to transform the way we think, the way we communicate, the way that we deliver. We can't just do what Netflix does, right? We're actually redesigning our choreography.
And so Diana just mentioned the shift to systems, right? And you could say that like ChatGPT is just a new player, an actor coming in to mix up all our systems, right? So maybe everyone here is more convinced of our argument than normal. And I think things that I definitely feel this, and I'm sure lots of people here feel this too. being in the middle of all of these complicated systems, trying to write and build and run and evolve software sucks, right? It can be really difficult, right? If only it was just the code and it would be fine, but it's not. It's all of these other complex things. And so one of the reasons why I think it sucks, and that's what Diana and I are going to try and kind of talk to you about, is the role of architecture and the role we see of like deciding what software goes where and how we structure our software and things. So there's some old pictures, there's some old memes which describe how we think about architecture, right? And they're so obvious that Diana's got pictures. So number one, the way we do architecture is ivory tower architecture, right? So we developers, people trying to ship the code, are down writing our code, at our code IDEs, at our machines writing, and then up in the ivory tower are the architects, right? The ivory tower architects are far above us and they're telling us what to do. And even though everybody laughs at this, it still happens. My clients ask me to come in and sometimes sit in the ivory tower and sit on architecture review boards and tell teams of developers what to do and what not to do and all of this kind of stuff. And even when I tried to make that work by trying to collaborate more closely with teams and to understand what they're seeing and doing, it still was really hard, right? The ivory tower was getting in the way. So what lots of people did, and what I do, for example, is this next one. But this is another meme too, right? The ivory tower sucked for various reasons. So I was, as an architect, would go down to teams, to the coal mines, right? Down to the coal face, and work with teams and co-design and come up with the software architectures with the teams. But then there would be lots of teams I'd have to work with, right? So I'd have to do a little bit of work with you and your team, and then I'd have to leave before you'd implemented the code, before you'd put it into production and go off and help another team, and then I'd have to help another, and I'd move around all the time. So you still knew more about your code than I did, and more about your systems than I did, because I was running around. So no matter how I was doing it, I was still a bottleneck. I was still a blocker. But despite this, the reason I kept doing it is because we needed good architecture, right? As Diana will remind us again and again, we need good domain-aligned, cohesive, decoupled, team-aligned, constantly evolving architecture, because stuff changes all the time, right? This stuff doesn't stay still. So good architecture has a massive positive impact. It makes our lives easier, it makes our lives more fun. Bad architecture can make our lives suck. But the two ways that I've tried to do this over and over again, they don't fail, but they just hurt really badly, and it feels like they could be more efficient. The ivory tower and the coal face down in the trenches, hands-on architect, neither of those work very well. And it was giving me nightmares. So Diana calls this my drama slide, but I was genuinely having nightmares, stressing about this, right? And you could probably turn my stresses into three things, three specific reasons I was having bad dreams. Number one, I was making really slow decisions. So even I was just taking a long time to help teams decide whether to use Kubernetes or not use Kubernetes, or whether to do one architecture or another. Number two, even when I was fast, I was picking the wrong decision. I was telling them to do the wrong thing because I thought it was the right idea, but they knew more and they knew better. And number three, even if I was quickly making the right choice, I would frequently miscommunicate to them what I thought was a good idea. So the team would build something else because I had failed to communicate properly. And so there were all these things, and I was waking up, and it's not just me. I've spoken to lots of people who've done a similar job to me, and lots of us architects worry about this stuff all the time. And so it made me think, is there a different way, right? This is maybe, if I'm so stressed and I'm worried about the quality of the software and the people I work with, is there a better way of doing it?
So is there another way? This is where Andrew has taken us. Like we've had a lot of experience with what doesn't work and when we hit the iceberg. And at every event that I've attended, every organization I've worked in, almost every conversation I've been in, we endlessly debate what is architecture. What is architecture? What does an architect do? Big fight on Twitter. Someone said architecture is a bullshit role and the whole internet broke. And what do we mean by that word? But also, who gets to define it? Like, who gets to decide what that means? And when we talk about it, we talk about it so differently that we're actually describing completely different set of expectation and roles. So today, we aren't going to enter that debate. I think that it matters to debate it, but also it depends. What does a circumstance need? Like, what type of thinking, what type of problems are we facing, and what skill set really helps us to be effective and have impact in that circumstance? So we're less concerned with one specific definition, which I would argue would be bad architecture, to say this one thing applies to all universal circumstances. And instead, we're going to talk about architecture as a practice of skill sets that help us expand our IT professional toolbox, and also helps facilitate the work that we do the most. And the work that we do the most as architects is we facilitate thinking. Like 80% of the work that we're knowledge workers, and 80% of the work we're doing as complexity increases is helping to facilitate decision making, and not only answer the questions, but structure the questions. Find and define the questions that are most valuable for us to explore. And every system that we design is only going to be as good as our ability to facilitate thinking well together. The better we do that, the more success that we're going to have. And so from this point of view, architecture is a relatively technology-agnostic skill set. Like, how many people here code in the same language, use exactly the same technology tool set you did day one? Right? So, like, I don't touch anything that I touched in the beginning of my career. We're constantly evolving our skill set, but our ability to think well is the universal, right? We needed that in every situation. And this means this is kind of the stuck place, is that we imagine as we get promoted in engineering, those skills will just appear, right? That it's advanced engineering skills. But this has not been our experience. They don't necessarily go together. Practicing systems thinking, nonlinear thinking, pattern and relational thinking, this includes being able to cultivate self-awareness, to do collective reasoning, to learn to be able to craft responses instead of reacting to the drama that's around us. So it's a practice.
Yeah. So we know, and we definitely, like Mike's Feather's keynote reminded us, technology is moving fast. So in the world of where Diana's talking, meanwhile, everything behind us is moving super quick, right? So, and not only is technology moving super quick, but the things people think they can do with technology is moving super quick. The expectations of what our customers and our users think is possible from our software is moving super quick. And, like Diana pointed out, the expectations and the dynamics and the skills and the structures of the teams and the roles and the jobs we do, everything changes, right? It's all changing super quick. And so if we're trying to build some kind of software which at least lives for 3 days before ChatGPT makes us replace it, how do we kind of get that stability? And the way we need to do that is we need to look at feedback loops, right? We need to not spend 3 years thinking really hard and writing some software and not putting it into production. We need to work in a very different way to optimize for getting feedback as soon as possible, right? And so there's 3 ways that I use, and one of them we'll talk about a little bit more, but there's 3 big ways that I use to maximize the feedback loop. So number one, and hopefully lots of people already do this, when I'm doing architecture, and as Diana said, I design collaboratively. I am always the wrong person to design software, But I can bring my skills to help everybody come together to design software, and we can create better software. So that's one of the things I do as an architect. Number 2, I empower teams to make their own decisions as much as possible without me. Because it shouldn't be me that's in the blocker, that's in the middle, right? If you're good at writing code and you're good at doing software, then you should be able to make those decisions. And number 3, I focus on getting that software into prod and I think this was always important, and it was important when we wrote this talk, and it's probably more important over the last weeks and months. Getting code into prod and finding what you can learn from the code running is super important. So doing all of these 3 stages is key, but the most important thing is, if we go to the next slide, is doing it over and over and over again. Because thinking hard and trying to guess is not a substitute for trying something, putting it in front of users and seeing what happens, and then learning from that, right? That's the key thing. And then taking the feedback and the learning from that and putting it back into the next iteration. And so
one of the things as we started working on this and other things together is that Andrew and I have different experiences, and sometimes we used different vocabulary when we talked about our experiences, but we had far more in common than we had differences. And one key heuristic, I guess, that we share is that architecture is a solitary intergroup and intra-group activity, right? So it's something that's happening in your own mind, how to think alone and structure your own reasoning, and how to do that together with people who have expertise that you don't have, that you need to integrate, and also how organizations create the space and craft the ability to come and make decisions together. So what we put the word cloud together to say, so when people say, well, when are you doing architectural thinking? And it's generally when you're doing any of these types of things. When you're thinking about the relationships between software parts, when you're thinking about timing and choreography, so events and choreography, when you're thinking about conceptual integrity, something we'll talk about, and also when you're aware of the fact that systems are socio-technical, meaning you can't, if everything that's in production is what we thought and talked about. So if you need to dramatically change the architecture of production, you have to also change what you think and how you talk about it. So there isn't a big division between the people processes and the code because they inevitably reflect each other.
And so to pick up on, again, one of the themes and the thing that Diana just mentioned, there's human beings at the center, we are at the center of all of this, right? And what we're doing, if you kind of reduce it to this most important thing, what we're doing is we're making and taking decisions. Small decisions, big decisions. There are definitions from, I think, from Grady Booch and from Martin Fowler, and they say the definition of architecture is just all of the decisions that everybody took. You put them all together, and that is what the architecture is, right? It's the end result of all of those decisions. And what you want to do, if we're going to get this to work efficiently, especially in the modern world, we want to be able to react, or not react, but to respond rapidly to changing requirements and to changing needs and things, and to try and evolve our systems as the socio-technical systems which surround them and build them, and the environment where they run. As those environments change, we need to be able to react and respond and make new decisions and change our systems to work with that. And so, because I'm talking about decision, let's define quickly what we mean by decision. So, like with software architecture, there are as many definitions of an architectural decision, if you just Google it, as there are what is software architecture. But this is the one that has worked best for Diana and I. And Diana and I is like, we don't agree on everything, but there's some kind of key overlap. So this definition for us is super good. So it's Michael Nygaard, which comes from his blog post where he introduced ADRs, architectural decision records. And he said, it's a decision which affects the structure, so that's maybe the stuff we think of with software architecture, or the non-functional characteristics, how it does it, the dependencies, the interfaces.
Sorry.
Or the construction technology. So the reason we like this is, number one, construction technology also talks about how we build it and how we deploy it and how we run it, not just the thing at the end of the result. So, you know, I said there's the 3 steps. Those are all important, not just the bit at the end. The other thing, to bring back Diana's point, it doesn't say if an architectural decision has to be big or small or taken by an architect or taken by a junior developer on day one. That doesn't matter, right? It could be an individual decision, a decision taken by a single team, or a decision taken by all of the teams across your whole organization. They're all architectural decisions if they meet this criteria. So that's decisions. There's one more thing, right? And everyone again, and I keep saying ChatGPT, but the people are not worried about what ChatGPT can do for us. They're worried about the unintended consequences of what ChatGPT might do by accident. I'm worried about what my software does by accident if ChatGPT is nowhere near it. I think I know what I'm helping the software to do, but you put software into production, it never does the stuff you expect, right? There are always things that it does that kind of you don't predict. It's impossible to control. Even now, the software that we build, the simple software, it's impossible to control 100%. But what we can do, therefore, is do small iterations. So we do a small change and we release it to production. So we find out what the small change did instead of building a lot of changes and then hoping that it doesn't go weird. So that's what we do. Back to Diana. Oh, no, it's me again.
Yeah, your fun side.
So this is my fun side. So maybe, and the reason we added this slide is maybe you think, as my systems aren't that complicated, right? There's a limit to how I must be able to understand them. So let's consider a really simple system, right? We build system A. System A is our service, and system B is a service that's created by another team. We need a widget, like a thing, right, that we can't create, so we ask system B to create it for us. So we send a simple HTTP request, a GET message to the system B. System B makes us a widget and it responds. So we get a 200 OK with a response payload which gives us a widget, right? If it works. If it doesn't work, it gives us a 404 not found, or a 400 forbidden, or a 500 if it's broken. So all of these things are expected, right? So I can understand that. That's not complicated. But what, for example, if B starts going slowly? So B's still doing the job, it just hasn't replied to me and hasn't told me what's happening. So I'm system A and I get bored. So I think, maybe I'll retry. Maybe system A never got my first request. I'll retry my request. System B now has 2 copies of my request. So do we know we don't know what it's doing. Maybe system B is making 2 copies of 2 widgets for me because it doesn't know that I requested the same thing twice. Because B doesn't know that I only want 1 widget, but I'm just not very patient. So maybe B makes 2 copies of the widget and gives them both back to me. Or maybe B is clever and realizes that I asked for the same thing twice and gives me the same thing twice. Or maybe it's even more clever and it gives me back 1 copy of the one thing I asked for and it just says, oh, it's okay, I know that you asked for the same thing twice. We can't tell. We can't predict because we don't know how system B works. And even if system B works one way today, someone might change system B and it works a new way tomorrow. So that's complicated. It can get even more complicated if we get bored, system A, and we stop waiting and we return to our users and say, sorry, you can't have any widgets today because the widget maker is broken. Does system B know that we don't care about the widgets? Do we tell system? We haven't told system B that the widgets aren't required anymore. So system B is still making things for us, but we haven't told it that it's still there. So the potential states of the system, the combined all of these elements, is now very unpredictable. And this is just 2 pieces. None of us have built this simpler system. All of our systems are more complicated than this. And this is just a technical system. So Dan is now going to make it even more chaotic.
Well, yeah, and everything that we're saying definitely hides the complexity that we're talking about, but it does help us begin to develop vocabulary. So this is from Donella Meadows, an article that's also from the book Thinking in Systems. Highly recommend. That's like the primer for everyone. It's not about tech, which actually helps because you're not directly translating it into a particular solution. But she describes the most basic system in this way. You have inflows, you have the state of the system, and you have outflows. So one way that a simple way of thinking about this is a bathtub. So you want to take a bath, and the bath holds so much volume of water. You probably don't want to take a cold bath, so you have some ideas about temperature. So you adjust the inflows so that you're getting the right amount, right temperature of water. You close the drain so that it fills up, but you only close the drain until a certain point. So your goal is to take a bath. And when you begin, the discrepancy is equal to the emptiness of the bath and the fullness you eventually want. So that's the perceived state in between is over time, the discrepancy diminishes until you have the system has reached its goal and you then turn off the inflows, outflows, you make a change. So this state of the system box can be full of physical things, water, temperature of a room. Now, again, this hides the complexity because all systems are operating with a whole bunch of different inflows and outflows and a whole bunch of ways that it's being impacted as it's happening. But the other thing the thing that matters for us is that the bathtub can represent full of intangible things, like ideas. So when we're working in a particular software system in a particular organization, there's lots and lots and lots of ideas and opinions and what matters, what we should be doing, how we should be doing it, flowing in. And what we produce, what we decide, what we build, what we release into production is the outflows. And so when you're doing architecture, the way that we define it is you're working with others to decide, to invent, to come up with what's the goal. In this case, there's no easy bathtub is this high and it fits my body. There are many things you could do. There are many goals that you could have. So it is about helping to figure out the goals, the priorities for the system as a whole. And it's also about designing the process that will get you from the biggest discrepancy to the smallest discrepancy in the most efficient and effective way. So it's working in systems, but it's predominantly working in the systems of concepts. When we do this well, this is the creation of conceptual integrity. This is taking a whole bunch of good but unrelated, ideas that are not playing well together, that don't have a lot of good quality relationships, and using concepts to structure something that has integrity and has impact over time. And Fred Brooks says that conceptual integrity is the most important consideration in systems design. So when we often focus on trying to maintain control, and we actually aren't trying to maintain control as much as we're trying to maintain conceptual integrity, where the system hangs together. It's a cohesive whole. Its patterns make it efficient and effective and vibrant. As Andrew described in A and B, it's making good relationships between A and B and changing those relationships as the circumstances change. And so for me, an architectural decision is about relationships and patterns and paradigm. In other words, when we're transforming relationships between A and B, we're making architectural decisions, regardless of who is making those decisions. And when we're trying out different patterns, so we're sort of changing the goals and the way we reduce the discrepancy, then we're doing architectural decisions. And a big time we're doing architectural decisions is when the paradigm shifts. So for example, how many organizations had very clear goals for their technology, and then May of 2020? And a lot of their technology goals changed as a result of now being immersed in the midst of a pandemic where everything now is going digital. When you're in that type of situation, you're making architectural decisions. And so these are technical and product and business. They're an integrative understanding. I'm not making the business decision necessarily, but I do need to understand the mission that I'm serving. Yeah. So my favorite way of describing this is Donella Meadows says that we think that because we understand one, then we must understand two, because one and one make two, but we also have to understand and. And so the way that we think about defining what this practice is the art and science of and.
So despite all of this, maybe you're hoping that we'll tell you there's like a set of rules that you need to follow. There is no set of rules, but because, as Diana keeps saying, and I've said a few times as well, it depends, right? And it depends on lots of different factors. And if you're expecting hard and fast rules, like this is the thing you do, if you copy Netflix, then this will work. That won't work and your life will suck, right? I think everybody knows this, right? Even Spotify tell you not to do the Spotify model because they're like, it didn't even work for us very well, so. But there are structured ways of thinking. And so what we're going to do is, in the last section, we're going to share with you a structured way of thinking which allows you to do all of these things and allows you to bring all of these factors together in a way which responds to all of these forces. And so it's called the architectural advice process. So Diana's going to quickly...
Oops, 2 overdone.
Yeah, that's it. So, but before I tell you what it is...
Yes, okay.
Before I tell you what it is, Diana's going to remind us because there's some key things.
I forgot, right, because the first time Andrew said, this is the architectural advice process, I'm like, I get enough advice in my career. I do not. I'm not like asking for advice. And the tricky thing is that what's the definition of that word? So I looked up the definition, and it's guidance or recommendations that are offered in regard to a prudent future action. So this for me is about when I need other people's expertise. I can't, in these complex situations, I don't know everything. I need other people's expertise. And so what we mean by advice is the ability to make good use of other people's expertise. And what we don't mean is opinion giving. Like, technology is run on opinions. Like, that is our fuel. And they're fun. We'll be discussing opinions, I'm sure, at the party tonight. Opinions are great, but they are not architectural thinking. In order for them to be architectural thinking, you also need to be engaging the reasons that you have come to those opinions, and they also need to be changeable and defeasible as circumstances change.
So with that in mind, this is the architecture advice process, and it's as simple as this. The consequences are complicated and can be very rich and powerful, but this is the process. As it says, anyone can make any architectural decision, so it's not just architects, anybody can. But before doing so, the person who's making that decision needs to speak to 2 groups. Everyone who's affected, so other teams, for example, and people who have expertise in the matter. So if Diana's an expert in Kubernetes, which I hear apparently she is.
I so am, 100%.
So it would be crazy if I went and implemented some Kubernetes stuff if I didn't speak to Diana, because she'll tell me the good stuff and the bad stuff, right? It's her opinion and I can ignore it, but that's the thing. So this is the simple thing. But let's quickly kind of describe what this feels like, right? Because this is maybe too simple sounding. So, I need to remind myself here. At the core of all of this is there's a contract, right? For this to work, there's a social contract, and the social contract is I can make a decision, but Diana and everyone else I work with trusts that when I make that decision, I will do all of the things, I will seek the right advice, I will listen, and I will understand.
Actually, before that, we have the layer, the proactive engagement. Yeah.
Sorry, go.
No, it's okay. See, it's good, because what happened is, as we were kind of going through this, we heard my caveats, and then we put in slides to be like, here's a caveat. So the practice is proactive engagement, as Andrew is describing it, and it requires really 3 fundamental practices first. And one is self-awareness and metacognition, meaning that you're aware of your own thinking, right? So you're doing work to spend some time to sort out what you're thinking. So it's not just taking input from others, it's also synthesizing it in your own mind. And then also the ability to respond rather than to react. So we're a very reactive culture. And we say no, wrong, bad, wrong, all the time, right? And it's being able to have that reaction and create some space. And then it's also being able to practice systemic reasoning. So systems thinking and systemic reasoning, informal logic, are conjoined twins, basically. They're very interconnected. So we take these individual skills, and then we go to what Andrew is gonna say now.
That's why I didn't recognize the slide.
Oh, sorry, one more, and I forgot. Great, so the summary of this is when we're doing architectural thinking, we're synthesizing knowledge, experience, and sound judgment into decisions or solutions or theories or ideas based on valid reasons. And we're synthesizing not just our own thinking, although we are alone, and our teams and the organization, other people's knowledge and other people's experience as well as our own.
Yeah.
Okay, now really.
So now, what does it feel like? So a few quick examples. So example number 1, say you're in a team and you've read Accelerate the book and you want to start doing very frequent deployments, right? So I've told you you should deploy frequently and release to production often. So to do that, you need to add a small architectural change to your code base, which is to add feature release toggles, right? So you want to be able to release code which isn't ready, or deploy code which isn't ready, and turn it off, and then when it's ready, you can turn it on. So you can frequently deploy and get your code out to production as much as possible. So to do this, the team that wanted to do that would have to speak to 2 groups. So my team who want to do this, we're deciding, so we have the power to decide. But I need to speak first to all of the other teams. And the other teams who I need to speak to are the ones who, when I turn my features off, their lives will be impacted, right? And so there will be teams who are building their services to consume my services. Suddenly, some of my services are going to disappear, right? So they used to be there today, and tomorrow they disappear because I turned them off. So I need to speak to them and collect advice and find out whether this will be good or bad for them. And they can give me their advice and tell me what they think, and I need to listen to it. The other thing is I need to speak to people with expertise. So I would go out and I would speak to various people in the organization. I've done this in previous organizations, so I might go and speak to, like QAs always have strong opinions about these things. QA that I spoke to might, for example, remind me that testing has now become more complicated because they need to test the features when they're toggled on, and they need to test the features when they're toggled off. So that's more work. They like the idea because they want to be able to release more frequently because it reduces the risk, but there's more work for them to do. I might also speak to some architects who've done this in the past, and they say, this is cool, but you need to make sure you don't leave a load of code lying behind you in the code base afterwards. So that's fine. They also might recommend that maybe we thought we would use a simple Boolean toggle in code because it seems fine to us, but they might remind us that to change the toggle, I need to change the code, check it into source control, run the whole pipeline, and do a deployment. If I used an environment variable, then I could flip it on and off without having to do a code change, and then I can help the team who are consuming their copy of my service, because they can run it locally in a different environment with it toggled on. So this is good, right? So my decision, I'm still doing the same decision, but I've changed the way I'm going to implement it. So by doing this, I've moved fast, I've been able to engage all the right people, I've been able to gather all of the information, but we've been able to take the decision, and this is what's important. Not only have we taken the decision, but we're responsible for it. We haven't been told by an architect that we're going to do feature toggles and that we need to implement this. We have the power to take the decision, but we're responsible for implementing that decision, and it belongs to us. It's not someone else's fault if it breaks, it's our fault. So the quality and the result of this is better. So that's one kind of way that the advice process can work. But what about the people like Diana, right? So Diana is working as an architect, and she's looking across all of the teams, right? Not just one individual team. She sees something which needs to be changed across all the teams, or a refactoring which needs to take place across multiple teams. Diana can still do this. Diana can kick off the advice process. She would still speak to the affected parties, all the teams who are involved. She would still speak to people with expertise, people in infrastructure, or maybe people in legal or product or whatever. But it changes the dynamic as well, because Diana was always reliant on teams to do the implementation, but she now needs to engage with them on a more equal level. She can't tell them what to do. She has to therefore listen to them to understand their thoughts and feedback and things on this decision, and incorporate that into the decision. And by doing that, and this is one of the powers of the advice process, it's a dialogue and a conversation between people, as opposed to someone goes into an ivory tower and makes a decision and tells people what to do. So it very fundamentally changes the dynamic of what's going on. So I think that's me. Yes.
Do you want to sum up the...
Yeah, sorry, so I should have told you to move the slide. But these are the three roles, right? So you can be a different person, you can play a different role at different times, depending on whether you're doing the deciding or your team's doing the deciding, or if you're an expert or whatever, because some things you're an expert in, some things you're not, right? Some things you're affected, some things you're not. So the roles change. But what is really powerful is the power moves to the place where the decision is needed, as opposed to waiting for it to come from architects in the center. So it can be super powerful.
So we had a bit more in case we had more time, but we don't have more. Yeah. I want to make sure that we have time for questions, because I know that you'll have one. So I'm going to skip the slides ahead a couple. Oh, and just before we finish, let's just do this. So I am teaching a course, a number of different courses, but one of them is a writing as thinking course. If you're interested in improving your ability to do written communication, to facilitate your own and other people's thinking, that's in September. Also, the early release of my O'Reilly book will happen sometime this month. And I publish a weekly newsletter about the skills of moving from software systems to thinking systems. Also do this work out in the real world, should anyone have such a need.
Yeah. And I'm also obviously interested in this a lot. So at the same time as Diana, we're like kind of running alongside each other. I'm also writing a book on exactly this approach, a different approach to making software decisions and facilitating software architecture. And if you want to know more about the advice process, this began with a blog post. Well, it began with experiments with clients, and I wrote it as a blog post, which is the link here. So if you want to read the blog on Martin Fowler's website, there's lots more ways to fail, anti-patterns to look out for, etc., etc. So there's lots of extra stuff there.
Yeah.